Hello everyone. Once again, I am Sachin Charbhe from Brazil College of Engineering. Okay. Uh, Today we will discuss the feedback amplifier. This is the unit fifth in your Mumbai University syllabus. Okay. So first we will see the what is feedback. So in the process by which the fraction of output energy is injected back to the input is called as feedback. Means the output is feedback to the input to correct the error. So it is called as the feedback. The amplifier using the techniques are called as the feedback amplifier. So this feedback is used in amplifier. Okay. So there is the two type of feedback. We know that is the positive feedback and negative feedback. Okay. In uh, positive feedback we use in oscillator and negative feedback we generally use in the amplifier that we seen in the large signal amplifier in previous unit. Now the characteristics of basic amplifiers, there are the four main characteristics or important characteristics. First is the voltage gain, input impedance, output impedance and bandwidth. So these we had already studied in the large signal amplifier, multi-stage amplifier. Okay, voltage gain also the very much important factors. Okay, so the output of the amplifier is depend on the gain, how much gain we multiply to the input, then input impedance and output impedance. We have to match the impedance of the device to the output impedance of the your amplifier and input impedance of the your device. Okay. Now bandwidth. So according to the bandwidth, you have to select the devices. Okay. So these parameters are more or less than the less fixed for a basic amplifiers. Okay. Then what is the need of the feedback? So first, the parameter of a basic amplifier is required to change as per the need. Okay, we can change the feedback. Okay, how much feedback we require. These changes can be brought about efficiently by introducing feedback in the amplifier. Okay, now the classification of feedback. So we already seen there are types of feedback, negative feedback and positive feedback. According to the negative feedback and positive feedback, we can select the amplifier and oscillators. Okay, so these two type of feedback. Then first we will see the what is the negative feedback. When feedback signal decreases the net input signal, the feedback signal is 180-degree out of phase with respect to input signal. It is called as negative or degenerative feedback. Okay. And what is positive feedback? When feedback signal is increases the net input signal, that is the feedback signal is in the phase with the input signal, is called as the positive feedback. Okay, means where we get the 180-degree phase shift, that is negative feedback, and we get the without phase shift, that is the positive feedback. Okay, then this is the feedback concept. Okay, look at this diagram. Here we use the amplifier and feedback element. Okay, input signal. So that is the complete simple diagram of the feedback amplifier. We have to give in the input Vi. Okay, and we are getting the output signal Vo. So here Vi is given to the amplifier and output of this amplifier is connected to the multiplying factor beta, and then again this Vi is again adding in the this summing or this signal. Okay, it may be this is the negative feedback. Here if the plus sign is there, then that may be the positive feedback. So that is depend on the feedback amplifier or depend on the feedback element beta. Okay, so it is also work on the Bar-Coussin criteria. Okay, that is a beta. Okay, a beta is less than 1 or greater than 1 or a beta equals to 1. So that will be discussed in next PPTs. Okay, now depending on the relative polarity of the signal being fed back into circuit, one may negative or positive feedback. Negative feedback result in decreases voltage gain for which the number of circuit features are improved. Positive feedback drives the circuit into oscillation as various type of oscillator. So that we already discussed. So positive feedback is used for the oscillator, negative feedback is used for the amplifier. So the typical feedback connection is shown, that is we are already seen in previous slides. So in this is the feedback amplifier. Now the input signal Vs is applied to the mixer network, that is the mixer means that may be plus or minus signal, where it combined with a feedback signal Vf. Okay, difference of this signal Vi is then the input voltage of the feedback. The portion of amplifier output VO is connected to the feedback network beta, which provides reduced portion of the output as feedback signal to the input mixer network. Okay, if the feedback signal is opposite polarity, the input signal as shown in figure, negative feedback that we are showing, although the negative feedback result in reduced overall voltage gain and number of improvement are obtained. So these are few points. There are the 6 main point. How to do the improvement? First, higher input impedance, that we know. We required the higher input impedance. Then better stabilized voltage gain. We required this gain, but that is stabilized. Then improved frequency response. Then lower output impedance. We have to keep the output impedance very low. Then reduce noise and more linear operation. Okay, so these are, in this way we can improve the negative feedback result. Then feedback connection types. So there are 4 basic ways to connecting the feedback signal. Both voltage and current can be fed back into the input, either in series or parallel, either in series way or parallel way, and it is term related to the voltage and current. So it may be first voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So let me see the details using the details diagrams. So this is the voltage series feedback. So here, that is feedback gain AF equals to V0 greater than Vs. Okay, so this is the Vs source voltage, that is we applying to the amplifier. Okay, that is the Vi, and as well as positive is going to the amplifier and negative that is going to the feedback element beta. So here is the Vf, that is beta V0, that is Vf by the V0 means feedback voltage by the output voltage, that can be calculated by beta. Then gain of the amplifier, that can be calculated by output voltage by the input voltage. Okay, so here is the load resistance, here we can get the output voltage, that output voltage again fed back to the feedback element. Okay, so in this way this is the series diagram, voltage series feedback. AF is V0 is greater than Vs, whatever the source voltage we applied, so we get the output voltage is more than that. Then voltage shunt feedback, so here is the term shunt feedback, so it is AF is equal to V0 is greater than Is, that is the source current. Here we are applying the source current, here we are getting the input current. Okay, then If, that is feedback current, is nothing but the beta into V0. Then beta is usual in terms of current, feedback current by V0. Then here V0, that is feedback to using the beta element to the input, that is input current. So this is the shunt because it is related to terms with the source input. Okay, now the next is the current series feedback, that is output current is greater than source voltage. Here is output current is more than the source voltage. So here we are applying source voltage, but output, that is in terms of output current, so that is given to the feedback element. Again here beta can be calculated by Vf by I0 means forward voltage, feedback voltage by the output current. Vf is equals to beta into I0, and that is this sending to the amplifier, that is Vf beta I0. Okay, and we will get the IO equals to IO, output current equals to load current. So this is the series feedback. So this diagram we are to using number of times, and this is the basic basic feedback amplifiers. Okay, now current shunt feedback amplifier, this is the output current is greater than the source current. So here is the source current is applied, that is applied to amplifier. Okay, then output of this current is again sending to the sending through feedback element beta. Here beta is purely the feedback current by output current, and feedback current is nothing but the beta into output current. Okay, here is the input current, here is the output current. Okay, so this is the current shunt feedback element where is the output current is greater than source current. So now we will see in the summary of gain feedback and gain without feedback or with feedback. So there is the we will understand this point. Gain feedback without feedback, that we consider the A, feedback we consider the beta, and gain with feedback we consider the AF. Then there is the four types of amplifier, four type of feedback amplifier we studied, that is voltage series, voltage shunt, current series and current shunt. So in gain with feedback, that is V0 by Vi, that is in voltage series, V0 by II, that is voltage shunt, V0 by Vi, I0 by Vi, that is the current series, and I0 by I, that is current shunt. Similarly, if the feedback element beta, that can be calculated by in voltage series Vf by V0, in voltage shunt If by V0, current series Vf by I0, and current shunt If by I0. Then gain with feedback, that is V0 by Vs source voltage, V0 by Is current source current, that is in the voltage shunt. Then current series, that is purely output current by the source voltage, and out in current shunt, that is output current by the source current. So this gain with feedback diagram is, that is in tabular form. Then the voltage series feedback. So for that we have to study the voltage shunt feedback, voltage series feedback. This is the diagram of the voltage series feedback. This diagram we are referring for the detailed study of the voltage series feedback. Okay, figure shows the voltage series feedback. Okay, if there is the no feedback, that means Vf is 0, so we will get gain directly, that is the output voltage by the source voltage, or you can say that output voltage by the input voltage. Okay, and if a feedback signal Vf is connected in series with the input, then input voltage may be changed. Input voltage is equals to source voltage minus feedback voltage, that we know that. Okay, then how to calculate the output voltage V0? So that we know that output voltage is nothing but the gain into the input voltage. So here we put the gain A, and what is input voltage? Input voltage is nothing but the source voltage minus feedback voltage. Okay, now multiply the gain, that is AVS minus AVF. So we'll get AVS minus AVF. So what is the feedback voltage? That is, we know that that is in the beta time into output voltage. So we put this value A into beta V0. So we will get 1 plus beta A into V0 equals to A into Vs. So we can calculate the overall voltage gain in the gain with feedback is AF. Okay, feedback gain, that is V0 output voltage by source voltage, that is A by 1 plus beta A. So this is the standard. So some numerical also may be asked. Okay, now the voltage shunt feedback. So for this voltage shunt feedback, we have to refer the voltage shunt feedback diagram. Okay, so this is the voltage shunt feedback. Here input we applied the source current, output, that is the output voltage V0. So beta we will get the IF by V0. Okay, so in voltage shunt feedback we will see in detail. Okay, so feedback gain, that can be calculated by output voltage by source current. Then what is output voltage? That is nothing but the gain into input current, or II. Then what is source current? Source current is the addition of two, input current plus feedback current. So again detail, A into input current divided by II. So what is feedback current? Feedback current is nothing but the beta V0. So again AI equals to I plus beta, we have to put the value of V0. What is output voltage? That is the gain into into input current. So using this we will get the A equals to 1 plus beta A, because there the input current will be get cancelled. So we will get the feedback gain, okay, in the voltage shunt feedback. Now input impedance with the feedback. So voltage series feedback, the more detailed voltage series feedback connection is shown in figure, okay. So that we already studied. So input current is nothing but the input voltage by Zi. Zi is using for the terms impedance, okay. So what is input voltage? That is Vs minus Va, means source voltage minus feedback voltage divided by Zi, input impedance. Then Vs, we are putting the Vf, that is beta V0 by Zi. Then Vs minus beta V0, we have to put the gain into the input voltage. So again simplify this, input current into the input impedance equals to Vs minus beta AVI. So Vs in terms of II, input current minus input impedance plus beta AVI. So here the input current into Zi plus beta input current into input impedance. So we can calculate the feedback in feedback input impedance. So feedback input impedance is nothing but the source voltage by the input current. So finally we get the Zi equal Zy into the 1 plus beta A, okay. So this may be asked. Then this is the diagram for feedback voltage series feedback connection, okay. So here is the Vs. So here we get the input impedance with feedback, okay. Here the output impedance with feedback. So here we shown the, that is the Zi into AVI. Here is the Vf forward feedback voltage equals to beta V0. Beta is as usual feedback voltage by the output voltage. Then gain of the amplifier we can calculate, that is output voltage by the input voltage. Then beta, that is also gain of the feedback element, that is calculate the feedback voltage by the output voltage. So in general AF, that is V0 by Vs, that is A plus beta A. Now the voltage shunt feedback. So more detailed voltage shunt feedback connection is shown in figure. The input impedance can be determined by, so here we have to explain this diagram using the voltage shunt feedback, okay. Here we have to showing the source input current, okay. So here we showing the that is current dependent source, okay, or dependent source. Then Zi into A into current element, input current. Then here is the output is V0, Z0, and here is the Zi. Then beta can be calculated by the forward current by the output voltage, okay. So this is really opposite the series. Then we can calculate the Zi, that is the input impedance related to the current, input current feedback input current, that is input voltage by the source current. So we know that source current is the addition of the input current plus the feedback current. So Vi equals to, now again put the feedback current. Feedback current is nothing but the beta into V0. So after putting Vi into I, Vi is nothing but we have to multiply this to simplify this. So Vi by II into II plus beta V0 plus II. So this II is 1, but we know that the input voltage by the input current is nothing but the input impedance. So ZIF is equals to Zi plus 1 plus beta A. So now the output impedance with feedback, okay, voltage series feedback. The voltage series feedback circuit that we studied already in figure provide the sufficient circuit details to determine the output impedance with feedback. The input impedance is determined by applying the voltage V, okay. So we will get the current and source voltage shorted, the Vs equals to 0, voltage V is then. So we can we will get V equals to I current into Z0 output impedance plus A into Va. If source voltage is 0, then we will get the input voltage equals to feedback voltage, that we know that. If voltage can be calculated, the current into output impedance minus AVF. So we are putting this minus AVF, then IZ0 minus A. So VF is nothing but the beta V. So again we have to rewrite this equation. So V equals to beta AV equals to IZ0. After solving this, we will get the output impedance feedback, that is V current by voltage by current. So that is Z0 plus Z0 by 1 plus beta A. Then similarly the current series feedback, the output impedance with the current series feedback, it can be determined by applying the signal V to output and Vs shorted out. Okay, that is resulting the current and the ratio of V and I being in output impedance. So this is figure show the more detail, that is the current series feedback connection. Here is the Z0 is parallel to the current, here Zi is, that is the input impedance. Okay, here we have to given the source voltage, we are getting the input current, and here the we are sending back the beta, that is Vf by I0. And what is Vf? Vf is nothing but the beta into I0. So as usual, when the source voltage is 0, so naturally we will get the input voltage equals to feedback voltage. Then current we can calculate using the voltage by output impedance minus AVI. Okay, in terms of using that diagram. So V equals to Z0 minus AVF. So Vi equals to, we put the Vf, V by Z0 minus A into beta A. So beta A means that is the Vf. So we will get the Z0 1 plus beta A into I equals to V0. So ZOF output impedance, output feedback impedance can be calculated by simple voltage by the current. So equals to Z0 is multiplying by 1 plus beta A. So this is also the important. Now the effect of the feedback connection on input and output impedance. So this is in tabular form. Okay, so these are all we studied. Okay, so if voltage in series, if the input impedance that is increase, current series also increase, voltage shunt that is decrease, current shunt that is decrease. Okay, and output impedance that is decrease in voltage series, increase in current series, decrease in voltage shunt, and again increase in current shunt. So these four types we already discussed, and with their input and output impedance also, their formulas here directly written. Okay, that can be used while solving the numerical. So last we will take the numerical. In this unit, student, there may be the theoretical questions more, but sometime it may be asked the numerical also. So we will take this numerical for practice. Similar types of numerical you will get for the more guidance you will use, or you can refer the Boyle stat. Okay, so this numerical also given in the Boyle stat. Determine the voltage gain, input and output impedance with feedback for voltage series feedback having gain is given equals to minus 100, input resistance that is given 10 kilo ohm, output resistance that is 20 kilo ohm. For feedback of beta factor is given, that is minus 0.1, and another beta is 0.51. So that is 0.5 minus 0.5. So you have to use the equation before whatever the equation we studied. Okay, that is the feedback gain can be calculated by A equals to 1 plus beta A. So we have to put the value. Gain is minus 100 is given, then 1 plus beta is minus 0.1, again 100, so you will get the minus 9.09, that is the feedback gain. Then input impedance can be calculated by Zi into 1 plus beta A. So put the value, you will get 110 kilo ohm, that is the input impedance or feedback input impedance. Feedback output impedance can be calculated 0 by the 1 plus beta A, and this is clearly mentioned, that is voltage series feedback. So you have to use the formulas for the voltage series feedback. So you will get the output in impedance, that is 1.82 kilo ohms, and same parameter we have to use for the next, that is beta equals to minus 5. Only the beta element is changed, so you will get the feedback gain, that is minus 1.96, then input impedance, that is 510 kilo ohm, and output impedance is 392. So what you understand? So that is depend on the beta factor. If beta factor is less, so you will get the your input impedance and output impedance. Input impedance of feedback and output impedance feedback is very less, while if the beta is more, then your input impedance and output impedance feedback is increase. Okay, so thank you student, thank you very much.